All right, so here's our example to see what that sample size calculation looks like in practice. So we have a sociologist who wishes to conduct a poll in order to estimate the percentage. So I want to take a moment here. We're estimating a percentage. This here, percentage, is a way to say proportion. Estimate is a way to say we want to do a confidence interval. So just throwing this out there because on the optional final, there is a sort of matching methods to what we're trying to do section. Of Americans who judge that affirmative action programs for minorities and women should be continued at some level. What sample size, okay, so this one's a little bit easy. We're looking for n equals, should be obtained if she wishes the estimate to be within 3 percentage points with 95% confidence. So we're given two more values here. We have 95% confidence, that's our confidence level, which we know we can use to go look up a z star in that t-table of 1.96. I don't like how that looks. And we have this, we want our estimate to be within 3 percentage points. So this is just a weird way to say we want our margin of error to be no more than 3%, which is 0.03. All right. As soon as you know that you're doing a sample size question, right? As soon as you see this, we're going to write down the formula so we can make sure we get the points for showing off that we know exactly what it is we're trying to do, even if something crazy happens and we don't know how to fill in this entire thing. So this is the formula straight off that formula sheet, right? All I'm doing is going, okay, they use the word percentage, which is another way to say proportion. We want a sample size. We're here. All right, so I've written that down. We know some of this already. We talked about we have our z-score, 1.96, our critical value. We have our margin of error. We did that as well. That was our 3%, 0.03 squared. And the part A says she uses an estimate of 85%. So we have a percentage. It's not the real thing. It's an estimate. So there's our hat. So this would be using 0.85. And then our Q hat is 1 minus that, 0.15. Now, this obviously is not the best estimate to use. It's super outdated. But let's see what we get if we do this. Got my calculator, handy dandy. 0.96 times, squared. And most of the mistakes on this are just people typing things into their calculator and forgetting a square or something like that. So again, just write out, make sure you write down all your work so that you can get partial credit. If something crazy happens, I'll usually give a lot of credit here. So 544.2. And remember, for sample size, we always want to round up. So we're going to report out that we should go sample 545 Americans rather than 544, even though 544 is closer. Okay, so the next question says, what if she doesn't use any prior estimates? So we're going to throw away this estimate of 85% from 1999 because it's super outdated anyways. Same formula. We still have the 1.96. We haven't changed our confidence level or anything else. We still have our margin of error of 3%. But now we're going to use that 0.5. I'm going to say, okay, if I don't know p hat, I got to use a p hat. I'm going to use 0.5. And watch what happens. I'm going to bring back this calculation. And I'm going to change, I'm going to change the 15, I'm going to change the 15 to a 50 and the 85 to a 50. Now we need 1067.1 or 1068 people. So we can see we need nearly double the sample size without a prior estimate for P. Now, this is obviously a particularly egregious example. The further a p-hat the estimate is from 0.5, the larger the difference would be. If this old sample had been 52%, using 50 wouldn't have made a huge difference. But it also points out that it's probably better in real life to go safe rather than sorry and always use 50%, because if your sample is off, you could end up not getting the margin of error that you want.